Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and understanding. Question 10. Wide aromatic liquid containers with bulbs glowing at the bottom are used for decoration purposes in a garden. At night, instead of switching off the bulbs, the caretaker chooses to place a floating opaque disc at the center of each of the containers. In doing so, the bulbs become invisible from the surface. Determine the minimum diameter of the circular opaque disc that the caretaker should place on the surface of the liquid in each of the containers. The height of the liquid in each of the container is 4 under root 3 centimeter and the refractive index of the liquid is 2 by under root 3 centimeter. So this question is an example for application of total internal reflection. Now, if the rays of light, they come from the bulb and whenever they reach this surface, they will come out, but they will remain inside the surface only when the angle of incidence is greater than the critical angle. So we want that all the rays of light should be inside the container only and they should not be coming out of this because of this disk. So as we keep the disk on the container, it will cover the rays that are coming out. So only the rays which are reflecting back in the liquid, they will be remaining. So we want the minimum diameter, and for minimum diameter, we need this distance, let me call it as R, has to be minimum. And this will be minimum when I is equal to IC. So first of all, find the critical angle for this surface. So we know critical angle for the surface is given as sine inverse of, so IC, it is equal to sine inverse of 1 upon mu. Since the outer surface is air, so I can write 1 upon mu. Otherwise, it has to be 1 upon mu 2 upon mu 1. But mu 1 is 1 only. So IC, it is equal to sine inverse of 1 upon 2 by under root 3. So mu is given to us as 2 by under root 3. It is given in the question. Now IC, it is equal to sine inverse of under root 3 by 2. And that will be equal to 60 degree. It means this angle for minimum R has to be 60. And now if this is 60, what I can do, I can conclude this thing that this angle is 30 degree. Because this is the normal. If this angle IC is 60, then the angle, this one is 30 degree. Now let me draw the triangle and call the triangle, let me give the name to the triangle. This is B, this is a D, and this is P. So in triangle BDP, tan 30 is perpendicular upon base. Perpendicular is BD divided by DP. BD is nothing but H and DP is R. So I can write tan 30, it is equal to H by R. So R will become equal to H upon tan 30 equal to 4 under root 3 divided by R. So I can write R is equal to 4 under root 3 divided by tan 30. So that will be equal to 4 under root 3 divided by 1 by under root 3. Tan 30 is 1 by under root 3. And that will be equal to 4 multiplied by 3. So R has come out to be 12 centimeter. So this is the value of R. But in the question, the question has asked that we need to find the diameter. So diameter D is equal to 2 times R. That will be equal to 2 into 12, that is 24 centimeter. So this is the minimum diameter of the disc that needed to be placed so that all the light, it reflects back into the liquid itself. Keep learning, keep practicing, keep excelling.